Welcome to the operational monitoring demo for the real-time instrumentation of the Modular platform, sponsored by the Modular Foundation. What is metrics instrumentation? In this context, it is the real-time operational visibility of the Modular stack for the following areas. The first being performance. Here we measure throughput and processing time for the underlying processes and subroutines. For example, we have instrumented the incoming requests and outgoing notifications in the ML API adapter, thereby allowing us to see the performance of transfers for both incoming requests, i.e. prepares, and callbacks, i.e. fulfillments. Additionally, this also allows us to monitor notifications being sent to FSPs for both performance and health reasons. The second area being health. We also use these instrumentations to determine if Modular services and supporting backends, such as data stores and infrastructure, are operating as expected. For example, we can determine if our infrastructure resources such as CPU, memory, or even disk space are overutilized. The last area being alerts, which provides the capability to place alerts such as emails or dashboard indicators for any of the above areas. For example, we may add an alert for the processing time metric for the ML API adapter. This would allow us to be alerted if incoming requests or even notifications are taking longer than some predefined service level agreement. Another example would be to place an alert on the infrastructure disk usage. This could provide a notification indicating that more than 80% of our disk space has been used, thereby enabling operational teams to proactively remedy the situation by increasing disk space or perhaps investigating further if unexpected. For the reference implementation of the Modular stack, we have used Grafina, which provides the capabilities to collect and visualize these instrumented metrics. Grafina is a portmanteau of two separate products, which are both open source with a large active community. The first being Prometheus. This provides a time series data store where metrics are persisted and also the supporting components to collect and ingest metrics from the Modular services or underlying infrastructure components. Prometheus also provides a wide range of client libraries and exporters for different languages and target runtimes, such as Docker and Kubernetes. Its developers are also proponents for the Open Metrics Working Group developing a new standard for metrics exposition, which will be adopted into future product and client library versions. More importantly, Prometheus's pool-based metric collection approach has a minimal performance impact on Modular's core running processes and infrastructure resources. Moving on to the second product, Grafina. This is the visualization tool that is used to easily view and create dashboards from the collected metrics stored in Prometheus. It also provides the alerting capabilities previously mentioned. Most of the infrastructure dashboards you will see in this demo are provided free by the community, with the Modular dashboards being created by the core OSS team. Let's start the demo. Opening up Grafina, we can view the available dashboards imported from the Modular Helm Git repositories monitoring directory, which also contains a README for more information on how to install and configure the Grafina stack. See the link displayed at the bottom of the screen for more information. Starting at the top, we have the data store folder, which contains 3 dashboards specifically for monitoring MySQL, as well as the Bacona Extra DB specific metrics. This can be used to monitor the account lookup, quoting, and central ledger data stores. The Kubernetes folder contains 2 dashboards, the first providing monitoring for Kubernetes clusters. This is where one can view CPU and memory resources for containers, pods, and even the underlying infrastructure. The second provides monitoring for Kubernetes deployments, showing the deployment state-specific metrics. The messaging folder also contains 2 dashboards, specifically for monitoring Kafka clusters and a more detailed view of the currently available topics. Here we can view the cluster resource usage as well as the metrics for message throughput and consumer lag. The last folder is Modular-specific dashboards. We have 2 for central ledger, one for monitoring the central ledger at a service level, and the second focusing more on the detailed subroutines like caching and data store operations. The ML API dashboards contain monitoring capabilities for the FSP IOP transfer API for both ingress and egress operations, as well as providing end-to-end business-oriented metrics for the entire transfer. This also includes the individual legs for prepare and fulfillment. It is important to note that these business metrics are dependent on the distribute trace headers. Please refer to that demo for more information. As such, the end-to-end metrics would only be applicable if all FSBs are participating in the trace. We also have a dashboard for legacy simulators where we can see basic metrics for incoming transfer operations. This is mostly useful for performance testing. The last dashboard, the Node.js application dashboard, provides more detailed Node.js metrics across all instrumented services, such as detailed CPU and memory usage, by the underlying node runtime. Let's open the Modular ML API dashboard and start sending some transfers through the system. First, let's start at the time range options on the top right of the screen. On this drop-down, one can select the configured relative time range between and including 5 minutes to 7 days. And on the left side, we can manually enter the desired time range. Further right, we have the manual refresh button, followed by the automatic refresh options. On this drop-down, we can select a configured refresh time for this dashboard ranging from 5 seconds to 1 day, with the first option off, disabling the refresh functionality altogether. Through the magic of video editing, I will move forward in time to show you the results of a completed run. Here we see a collection of graphs that reflect 100 synchronous transfers being sent through a non-performant dev environment system using the Modular Testing Toolkit's iteration runner. Take notice of my mouse pointer. When moving it over a graph, a pop-up window will appear showing the visualized graphs and each of the metric values. One can interact with this graph by clicking on the colored areas or even zooming into an area, as you will see shortly. We can also choose which of these metrics are visible, which is useful when there is a lot of visual noise. Let us zoom into a region using our mouse. This dashboard contains several panels, with these 4 being the most important. At the top, we have the summary, which contains a bar graph representing a histogram of the end-to-end transfer time, i.e. including both the prepare and fulfill leg, the total count of the transfers being grouped into one of the buckets, total, less than 1 second, more than 1 second, and so on up to more than 5 seconds. This is useful to see the distribution of total transfers by processing time, which may impact an FSB's and ultimately a customer's experience when exacting transfers through this Modular dev environment. In the Modular panel, we have 2 graphs. The first representing the transactions per second throughput for metrics instrumented by the ML API service component. This includes the end-to-end transfer, which we will refer to as financial transactions per second from this point on. This is instrumented by the moja_tx_transfer metric, and the separate prepare and fulfill legs are described by the 2 similar metrics differentiated by the suffix prepare and fulfill, respectively. The transfer API prepare and fulfill instrument the incoming API processing throughput for the ML API adapter service component specifically. The notification deliveries metrics, which are instrumented by the ML API adapter notification handler, is for sending requests and callbacks to external FSBs. Pay close attention to the additional metadata included after the metric name, specifically the actions, prepare, or commit, i.e. fulfillment. The HTTP response, such as 200 or 201 from the FSB, and the overall status, such as success as shown here. This additional metadata is included as labels to the instrumented metrics and adds multi-dimensional capabilities to the metric. For example, we could report our notification deliveries based on all dimensions, ignoring the action, response code, and status, or we could just report on the status. In this case, we are using all 3 dimensions simultaneously to give us more useful information. In the graph below, we have the same metrics, except the values reported here are for the processing time. Here we can see, for example, that the moja_tx_transfer metric took 390 milliseconds average for the selected time range. In both graphs, we have the min, max, average, and current instantaneous value shown in table form. The current ops panel is more applicable during a live run. It provides the real-time instantaneous values for most of the previously discussed metrics. For example, the financial transactions per second represent the moja_tx_transfer metric previously discussed, and so on. The final Kafka panel displays the consumer lag for the ML API adapter notification handler, specifically showing how many notification messages have been queued in the notification topic and are yet to be processed. Here we can see an average lag of 92 messages. In general, the consumer lag metric provides a great way to determine the overall health of the transfer-related components, as healthy running systems would always result in a consumer lag metric being predictable and bounded. Thank you for listening. I am Miguel de Barros from Modularbox, a Modular principal architect working on the open source funded development project, part of the team designing and engineering core Modular services over the last 2 years, and a member of the Modular Design Authority.